Hey guys. Sorry, you caught me doing some light.
Hey! Mr. Thomas is here. Man, just chilling. You know, recycling is important, and I really like to get into what I'm passionate about. Recycling is one of them.
Save the earth.
Exactly. All right. Speaking of Earth, it's made up of many different families.
Yeah. Yeah.
All right. And one of those families is family function. So that's what we're going to do today. Our goal is to analyze transformations of functions. So, Miss Colette.
Yes.
Go ahead and start us.
All right. This is such a super important lesson. The characteristics, the key terms, the key everything of this lesson will be used in every single chapter here on out. Every single graph, we're going to come back to these families of functions and the transformations. And so it's super important to understand what we're talking about today. So types of transformations. So we have translations. You can either have a horizontal shift or a vertical shift. How I remember horizontal is, think about the horizon is like, left to right. That's your horizontal shift. And then vertical is up and down. And then we have reflections, like a reflection in the mirror. It's like a mirror image. And then we have stretches and compresses. Okay?
Very good. Translations, it just means a shift of the graph of the parent function horizontally, vertically, or both without losing the shape. So when we say parent function, I didn't mean to cross out the parent. Parents are very important. But the parent function is the original function. So like right here, this red or orangish, the function is f of x. That's the original function. Notice it's kind of got the curves to it. Then if we wanted to move the function up or down, we could have a plus sign right here. So the parent function plus a number makes it go up. And then the parent function or the original function minus a number makes it go down. So we're adding numbers to it and then it changes. Sort of like, parents, they come together, they have children, and the children look similar, but they're also different. Same thing over here with horizontal translation. I made my recycling bin is limiting my mobility. But our parent function is the red one. And so to make the graph move left or right, instead of going from f of x, we're going to add a number inside the parentheses. And notice the plus sign makes it go backwards, and the negative sign makes you go forward. The rule that we're gonna do this semester is if we have any type of graph, so it will be like y equals something, x minus 2 plus 3. Our rule, and we're gonna look at this later on in more detail, if there is a number inside a parentheses or inside a absolute value bracket or inside
like
a
square root,
anything like that, you drop the number. So the number's 2. That looks like a question mark. That's a 2. And then you switch the sign. So this is positive 2. That is
perfect.
okay.
So basically, whenever you do your horizontal translation, it's opposite of what you would think, okay? So you always drop the number, switch the sign. Okay, so, thanks. So we have, looking at this table and graph, it says, how are the functions y equals x and y equals x minus 2 related? How are their graphs related? Okay, so if we have a table of values, we have our x's, if we plug in x and y's, here we have, our y equals x, we have a negative 2. But if we have an x minus 2, it goes from negative 2 to negative 4, okay? And then negative 1, if we have x minus 2, negative 1 minus 2 would be negative 3. Okay, so all of these are 2 less than. So if we look at their graphs, if you notice, our black would be y equals x. That's your parent function, which your black one is the y equals x. This is your equation. And then if we look at our translation, we have y equals x minus.
Oh, that calibration's a little off.
The translation went down too. So it went down 2. Every point on the graph is translated down to units, and that is because of this. The -2, that's right there. And that is a k, that represents the k variable. And so the graphs are related is everything is translated down 2 units. So down 2 units.
There we go.
Perfect.
Nice.
Calibration there.
Okay, so let's look at some horizontal stuff. So once again, our rule, and I beat myself to the punch on my last turn, but this function f of x minus 2 represents this transformation, and you see it in blue over there. So f of x is the black one. Notice our points are right there, and what I like to do, I like to just pick like one point. So I'm picking the left point right here, and then I look at my new function, and I know I'm going to drop the number, switch the sign, and so I know I'm moving to the right 2, and look at this, 1, 2. My blue function, which is the transformation of the parent function, is to the right 2. This is pretty simple stuff. But just like any time you learn something new, it can be a little tricky, so make sure you're asking for help if you need it.
Okay, reflections. So this is the other transformation that we're going to talk about. So you have reflection over the the y-axis and the reflection over the x-axis. So a learning tip is to imagine each axis as a mirror, okay? So if we have our f of x here, okay, this is our parent function in black. So if we take this and it's reflected over here, okay? It's like a mirror over the y-axis. So this is a reflection of f of x over in the y-axis, okay? Then if we look at from here to the blue, from black to blue, this is our parent function, and now it's reflected over the x-axis. So a reflection over the x-axis. So if it goes left to right, it's over the y-axis. If it's up and down, it's reflected over the x-axis.
Very good. All right, so reflecting a function algebraically. So it says, let g of x be the reflection of f of x, 3x plus 3, in the y-axis. What is a function rule for g of x? So the key words that I'm looking at are, number 1, I need to make sure I understand what the parent function is, which is f of x, but then the key word is reflection, so that's the mirror thing, and the y-axis, that means I'm going over the y-axis. So what I'll do, I could make it like a chart for this, but another thing that I could do is I know that I'm just moving left to right or right to left because I'm going over. Can you draw a line down the y-axis for me?
Absolutely, I can.
I'm going across the y-axis, so I'm going to have to move left to right. And so that deals with the x value. So they kind of draw like a little formula for you. That's fine. But really the easy way is just make sure that x is negative, and then when you combine it with that 3, you get g of x equals negative 3 of x plus 3. And then the quick way to do that would just be to maybe pick like 3 or 4 points, just randomly, and then just move them over, and then you should be able to get it. You could also graph this like a, this one's linear, so you could actually, this kind of looks like what we learned on a previous lesson from this chapter. This is slope-intercept form. And so you can graph this like slope-intercept form.
This is, black was a positive slope, and then our green is the negative slope.
Exactly.
Yeah, so that's the reflection across the y-axis. It just changes the slope from positive to negative, or vice versa. If it was negative, it could turn to positive. Okay, so combining transformations. So the graph of g of x, the graph of g of x is the graph of f of x equals 4x compressed vertically. Okay, so compression means tight, it gets smaller. by the factor 1/2, and then it's reflected in the y-axis. Remember y-axis. Okay, so what is the function rule for g of x? So we know it's compressed by 1/2, and then it is reflected by the y-axis, so it's a negative. So here we have, if we compress it, so we have 1/2 times 4x, so 1/2 times 4x, or 1/2 of 4 is 2x. And then if it's reflected across the y-axis, that means the slope changes, okay? So it was a positive slope, now it's a negative slope. So the function rule is g of x is equal to negative 2x. So basically what we did is we multiplied by a negative and we multiplied by 1/2, okay? And then then we get g of x is equal to negative 2x. So here with its stretches, so if a is greater than 1, so this a right here, the factor of 1/2, if it's greater than 1, it's stretched out. Okay, it grows at a faster rate. It's stretched out. If it's between 0 and 1, that means it's compressed because it's a smaller number. Okay, so that's those are two different stretches or compressions that we're going to talk about.
All right, this is just a summary of all the different types of transformations. What I'd recommend is, especially when you get to the quiz or the practice test, access this, all right? So maybe make a note in your notebook, go to this slide or go to page 102 in the book. All right, now we're dealing with some more applications of these transformations. We're gonna look at absolute value functions and graphs, and we're gonna be able to graph absolute value functions. This is pretty fun and pretty easy. So, absolute value graphs are V-shaped, all right? And they are symmetrical. Symmetrical means it looks the same on the right side and left side. The axis of symmetry is the vertical line of symmetry that goes right through the vertex, okay? And then the vertex is the meeting point of the V. So where the V meets, that big blue dot. And it is also either the maximum or minimum. And so what we mean by that is it's either the lowest point or the highest point. So on this particular one, this has a minimum of 0. And then that would be a maximum where it's going to go down. All right, so Ms. Collette, go ahead and show us.
Okay, so we have y is equal to a times the absolute value of x minus h plus k. Okay, so h we've seen, k we've seen, a we've seen. So those characteristics we are going to apply to absolute value graphs. Okay, so the stretch or compression factor is the a, and it's absolute value of a. So if a is greater than 1, it's stretched. So it's like a skinny V. It grows really quickly. And then if a is between 0 and 1, it's compressed. So that means it's going to grow slower and it's going to be a wide V. The vertex is located at HK. So H and K. So your vertex, remember the meeting point of the two graphs, or the point either up below or above the max or the min. That is H and a K, and we always drop your sign, or drop your number, flip your sign, and then K is as is. And then the axis of symmetry of the line is X equals H. So whatever number this is, remember the sign dropped, that is where the axis of symmetry is, the middle of it. And it always goes through the vertex. So if we were to graph an absolute value function, very roughly, so we know it's going to be a V since it's an absolute value, and then we have -4. So this -4 is outside of the absolute value, so that's represented by K. And the -4 says it's going to go down 4 units. So I'm going to go down 4 units, and it's just going to be a V like that.
There you go.
Okay, and your axis of symmetry is at 0. And there you go.
All right, if you don't mind erasing. All right, so I'm going to work through a couple more examples. Actually, I'm going to only do one example because I can only reach this way. All right, so what I like to do when I go to graph absolute values, all right? The main thing I need to know is I need to know the vertex, okay? And so that's what I need to know. But what I like to look at when I graph is I want to know just off the top of my head, what should this graph look like when I'm done? So the first thing I see is this is going to be a V because it's absolute value. And then I work left to right. And so I gotta ask myself, is it a V going up or a V going down? And since this is positive, it's gonna be a V up. So I'm just gonna put that there. And then I know my vertex, actually I'm gonna put my vertex somewhere else. All right, and then I know that I'm gonna use these, whatever number's in here with the X and this 2 for my vertex. So I just draw a little coordinate. I'm gonna move my graph right there. All right, so what number is inside here with the X?
0. There's nothing.
There's not a number in there, so that is just a 0. And then my 2 is outside of the absolute value box, so that's gonna be a positive 2. So my vertex is 0, 2, right there. And I draw my little V. All right. Now I think on Math Excel, when you use the drawing tool, it's gonna have you find the vertex and then you have to click one more point. The way you do that is you use the A, whatever the A is. Now I call this the kind of slope, okay? Because it's not technically called slope, but it works kind of like slope. So right here, there's an invisible 1, right? You can't see it. And so my slope would be 1. So if I just went up 1 and over 1, so on Math Excel, that's all you got to do. And then for my second point, it would work the same way, where if I go over a negative way, it's still going to work out, basically. Now, my graphing is not perfect, nor is the calibration, but that is how you do it. And then all that information about axis of symmetry, we'd say our axis of symmetry is on the 0, and then we would say this has a minimum, and that's basically it. All right, Ms. Collette, show us another example.
Yeah. Okay, so y is equal to x plus 2 in absolute value, and then plus 3. So let's look about the shape. So from left to right, there's no negative, which means it's positive, so it's going to be opening up. And then let's talk about our vertex. So we have H and K. H, we drop the number and switch the sign. So this positive 2 becomes a negative 2. And then we have a plus 3, so that's a positive 3. So we know this is our vertex right here. So if we're going to graph it, we're going to go to the left, 1, 2. We're going to go up, 1, 2, 3. That would be right here. Okay, we know it's a V. Our kind of slope is still an invisible 1, so we can go up 1 over 1, up 1 over 1 here, and we can draw our V. Our axis of symmetry is down the middle at -2, so x equals -2. And then this down here is a minimum, okay?
And a quick tip, you may have noticed this, but the axis of symmetry is always whatever that x value is, and the minimum or maximum is whatever the y value is on the vertex. So once you find the vertex, you can do a lot.
Everything you need to know is in your equation, which you can use with your vertex.
Absolutely. All right. We have one more. Okay. So right here, this is just demonstrating the effect of stretching and compressing. So the stretch and compress pertains to the slope. That's basically what I'm wanting you guys to see right here. So if we were to graph this function, we would see that the vertex would be at 0, 0, because there's nothing in there and there's not a number here. And so the only thing that we would change would be this slope. And so notice we go up 1 and then over 2, and then boom.
And then remember it's symmetric because of our axis of symmetry at x equals 0. We can also go up 2 and to the left 2. And that's how we get our left part of our V.
Very good.
No.
All right, one final example. I'll go ahead and do this one. I like how Ms. Collette did it without drawing the graph first. So, all right, so first thing I do is got to figure out what is the shape. I see the absolute value brackets. I know it's a V. Is it a V up or a V down? What do you think?
I'm going to go with up.
And why is that?
Well, because if you see here, this is a positive.
So yes, this 3, which is our kind of slope, is a positive. And so I know it's going to be a V up. I draw my little brackets, and then I just work left to right. So the -2, I drop the number, switch the sign, that becomes positive 2. This is a 4. That stays the same, drop it. And now, when I graph, I'm just gonna find my vertex at 2, 2, and then 4. Looks like I'm gonna have to add some more notches. And then to find my next points, to make my graph look good, I'm gonna use the kind of slope. I'll go ahead and change my colors on this one. I'm gonna use my kind of slope, and this is where it's not exactly slope, because slope would tell us rise over run, which that's what we're gonna use for our first point. I wanna go up 3, over 1, I'm trying to line it up, my shadow's in the way. And I'm gonna go up 3 and over 1 the other way. And then this is my graph. Notice it got a little bit skinnier, and we could say that x equals 2 is my axis of symmetry, or AOS. And then for my, actually, I'll ask Ms. Collette, do we have maximum or minimum here?
Because this vertex is at the bottom, that would be the minimum
Yes,
of your graph.
Minimum would be at y equals 4.
Nailed it.
Alright, that, I believe, is it.
It is it.
So, good luck. Look, I think you'll enjoy this.
Yeah.
There's somewhat of a learning curve on Math Excel with graphing absolute values, so just reach out to myself.
Absolutely. We are here for you, and you have 13 total questions.
Alright.
See ya. I need to take the trash out.
See you guys.